Hello, everyone. Welcome to the lesson on Principles and Applications of Mechatronic Systems. I'm the lecturer, Liang Guangrui. Today we look at Chapter 4, Servo Control Technology, Stepper Motor Drive, and Control. First, let's look at the learning objectives of this lesson. You should master the control methods of stepper motor rotation direction, speed, and angle, and be familiar with the stepper motor drive circuit, such as the principle and function of H-bridge driver circuit. Understand the functions and selection tips of stepper motor drivers. Understand the characteristics and applicable scenarios of pulse-type and bus-type control methods. And learn to set the relevant parameters of the stepper motor driver according to the actual needs. First, let's focus on the basic principles of stepper motor drive and control. The rotation direction, speed, and angle of the stepper motor are controlled by the power-on sequence or direction, pulse frequency, and quantity control of the stator winding respectively. The control signal generated by the controller can't directly drive the stepper motor, and it needs to be amplified by the power amplifier circuit before driving the stepper motor. We usually use an H-bridge driver circuit for power amplification. The H-bridge uses the base signal of the transistor, Q1 to Q4, to switch the coil current direction. For example, when Q1 or Q4 is power on, the current flows from left to right, while when Q3 or Q2 is power on, the current direction is reversed. Since the inductor current cannot suddenly change during circuit switching, the diodes D1, D2, D3, and D4 play a freewheeling role. We know that one-phase winding needs one set of H-bridge circuits to drive, so for two-phase motors, two sets of H-bridge driver circuits are needed. Next, let's talk about stepper motor driver. Stepper motor drive technology is well established, and engineering applications mostly use the drivers integrated with micro-stepping drive technology. They have functions such as driving, logic control, protection, and communication. It can be quickly connected to PLC or microcontroller. Control methods include pulse type, such as pulse plus direction, CW plus CCW, AB phase pulse, and bus type, such as EtherCAT, Ethernet IP. As shown in the figure, there are three typical pulse control waveforms of pulse type. The first is pulse plus directional mode. Pulse is the pulse signal, DR is the direction signal, and the high and low levels of DR correspond to the control of forward or reverse rotation. CW and CCW modes control forward and reverse rotation by the output pulse of CW pin and CCW pin. In ab-phase mode, the motor is controlled forward and reverse according to the phase relationship between phase A and phase B. For example, if phase B is 90 degrees ahead of phase A, it is forward and vice versa. Let's compare pulse and bus drivers. Pulse type control controls speed and position through pulse frequency and quantity. It is often used in single-axis, short-distance, low-cost scenarios, such as 3D printers and small robotic arms. Bus type control sends instructions based on the bus protocol, supports parametric control and reading driver parameters, has the characteristics of strong anti-interference ability, simple wiring, high cost, strong scalability, real-time dependence on the bus protocol, and high functional complexity. It is suitable for multi-axis collaboration, complex environment, and high reliability requirement scenarios, such as industrial robots and automated production lines. The following takes the domestic Zenlituan two-phase pulse type stepper motor driver as an example to show you the specific usage. The driver is mainly divided into power input, control signal input, drive output, current, and micro-stepping settings. We can see that the current and micro-stepping settings are printed on the surface of the driver. which is convenient for users to inquire. For example, SW1, SW2, and SW3 can set the working current of the stepper motor. Checking the ammeter, you can see that when they're all set to on, the average current is 2.0 amperes and the peak current is 2.4 amperes. When set to off, on, the average current becomes 2.57 amperes and the peak current becomes 3.08 amperes. The SW4 switch is used to set the half current or full current function. When it is on, it drives with full current. When it is off, the driving current is halved. It is recommended to set it to off in general purpose, which can reduce the heat generation of the motor by about 36%. However, if there is heavy motor load, the pause time is relatively short, and the acceleration and deceleration time is relatively fast. It can be set to on. SW5, SW8 switches are used for micro-stepping setting, and different switch combinations correspond to different steps per revolution. For example, when the switch configuration is turned to 400 steps per revolution, it means that the stepper motor can rotate once after the driver receives 400 pulses. Because the step angle of the two-phase stepper motor is 1.8 degrees, and it rotates once for every 200 pulses, so 400 corresponds to half-step operation. If it is turned to 51,200 steps per revolution, the driver needs to receive 51,200 pulses for every revolution of stepper motor, corresponding to 256 micro-stepping. Pulse-type driver is more suitable for occasions with few axes, short distance, and sensitivity to cost, while bus-type driver is more suitable for complex multi-axis control occasions. Finally, let's make a summary. Through this lesson, we have deeply mastered the relevant knowledge of stepper motor drive and control, including its working principles, drive circuit, driver function and control methods, etc. At the same time, we also learned the integrated functions of the stepper motor driver and the connection methods with the controller, compared the advantages, disadvantages in applicable scenarios of pulse-type and bus-type control methods, and master how to set the parameters like working current, micro-stepping of the driver according to actual needs. This lesson ends here. Thank you for listening. See you next time.